So for section 5 of chapter 1, it's a pretty brief section, but it's an important section, even though it's short. We're going to learn about the distinction between two types of analysis or two types of statements. So the first type is what's called positive analysis, or for us, positive economics. And these are purely descriptive statements that can be verified as true or false. A lot of times they are statements of if A, then B. So just for kind of a silly example, if I throw a ball in the air, it will come back down to the ground. Okay, so that's something that we can test and we can prove true or false. And again, this is a descriptive statement or a scientific prediction, right? So, one way to think about it is it's a statement of what is. How does something exist? What is true, in other words? So let's see. The way that I like to remember this, the definition for this one, is by thinking about what positive means, a little bit of word association, I guess. But basically, I think, well, what are the two types of test results on a drug test? A test that reveals, whether or not someone has consumed a drug. And the two results are either positive or negative. Now, hopefully you don't confuse this with the two different types of incentives, but in any case, it's a test, right? True or false. And so positive economics, positive test result, think of it that way. That's one way to try to help yourself remember this. But again, these are statements or scientific predictions, and they can be verified as true or false. So when you're trying to decide whether a statement is positive, ask yourself, well, can it be proven true or false? If it can, then it's a positive statement. The other type of statement is a normative statement. So normative economics would be, let me take a step back. So normative statements are statements about how the world should be or ought to be. And they are statements that involve value judgments, like whether things are good or bad. And in contrast to positive statements, these types of statements cannot be tested and proven true or false. There's no way to prove going to church is good. There's no way to prove that people should drive the speed limit. What you could prove is that people that go to church donate more money to charity. That is something we can test and reveal to be true or false. My hypothesis is that statement is true, but we would have to look at the data, the real world data, do some empirical science, and see whether that statement's true or false. But there's no way to prove that going to church is good. And the main reason for that is, well, you then have to define what good is, because what is good is ultimately a statement or a matter of opinion. And that's what makes it a normative statement, is that good is a matter of opinion. What is good to some people is bad to others, okay? And there's basically no objective truth about what is good and what is bad. On the other hand, we can look at data in the real world and see whether or not people that go to church on average donate more money to charity. That's something we can look to the data for and prove true or false. Okay. So yeah, a similar word association here that I like to use to help me remember this definition is the word normative has norm in it. And if you haven't already, maybe that makes you think of the word normal. Well, what's considered to be normal is entirely a matter of opinion, and there's no proving true or false what is normal. Okay, so just as an example there are some cultures in the world where it's normal for men to wear dresses. Okay, it's not normal here in the United States, but it is normal in other parts of the world. Are we right and they're wrong? No, it's completely subjective matter of opinion. You can't prove that men wearing dresses is good or that men wearing dresses is bad. These are things you cannot prove as true or false. It's just impossible. You could test whether or not societies in which men normally wear dresses, if those societies have better economies in terms of GDP. That's something you could test. That's something you could look at and prove true or false, looking again at empirical real world data. So using economics as an empirical science. It's very easy to confuse these two or forget which one is which. Just do your best to remember them. Try to use, if it's helpful to you, those word associations that I just gave you. But in any case, you will have to know this. And it is important for economics because we're mostly interested in positive economics, things we can prove true or false. We're not as interested in normative economics because it's really a matter of opinion. So, all right. So here is something interesting just to sort of help you wrap all of these different things we've learned in this chapter into one little tight burrito, something that brings it all together. So here's an interesting thing. Apparently this guy, Wayne Daly, who's a researcher at Georgia Tech, not far from us here at Georgia Military College, has developed apps that allow farmers to monitor their chickens' speech for signs of discomfort or distress. Now, I want you to take a second, maybe even pause the video for a minute or two, and think about the incentives involved for this gentleman, Wayne Daly. Why was he motivated to create this app? It seems like a very interesting app. He may have had different motivations. Think about why he may have been motivated. What incentives did he have to create this app? Okay. Now, you may have come up with one of these two incentives, these motivations, but hopefully you came up with one of them at least. But it could be on his part a humanitarian motive, right? Again, going back to behavioral economics, this idea of bounded selfishness, right? Not unbounded selfishness, but bounded selfishness, meaning that we actually do to some degree care about other people and perhaps even other beings such as chickens, right? So there could be a humanitarian motive here, but there could also be a profit motive because it could be that, and this is maybe the harder one to think of, but it could be that chickens that are more comfortable lay more and larger eggs, which translates into higher profits. So there could be a profit motive to chicken farmers as well. So I don't know Wayne Daly. I don't know what his incentive was. Maybe another incentive for him is just pure interest in research and developing such an app. That also, too, could be an incentive here that isn't listed in the slides, but there are potentially many different incentives for Wayne to have created this app. But here's at least two, right? Now, at the beginning of the chapter, we talked about women, slightly older, middle-aged women, and with higher educations and their decision to have children. And we learned that the number of women in this category that have children has gone up over the past several decades, or that the number of them that are childless has gone down to 20% roughly today from, I think, 35% 20 or 30 years ago. And, you should be starting to think about all the things that we talked about in this chapter and how that relates to this decision, right? So we talked about incentives. Well, what are the incentives for these types of women to have children? And what are the incentives for these types of women to not have children? So I want you to post in the discussion forum what you think their incentives were, what they could have been, what their, just tell me what their different incentives were for either having children or not having children, and indicate which is which. Also think about the other things we talked about, right? The fact that people have unlimited wants but limited resources. So how might that impact these women's decisions to have or not have children? How might the limited resource aspect play in? But put that in the discussion forum to not only take the place of your attendance, but also to hopefully stimulate conversation amongst yourselves for an improved learning environment. So let's think about those things going forward here. Now I want to take a look at a chart. So a big part of economics is looking at data in various formats. So here's a histogram, which is sometimes mistakenly called a bar chart. They're not the same thing, although they look very similar, but this is a histogram. We use histograms a lot in economics, other types of charts, pie charts, line graphs, all kinds of things. So you need to get used to looking at data and interpreting data from looking at these things. It's a huge part of economics. But so we'll go slowly through this one since this is the first chart we've looked at. But every time I look at a chart, the first things I like to do are look at the axes and make sure I understand what the axes are telling me. So down here on the x-axis is education level. And then on the y-axis, the label says percentage of women aged 40 to 44 who have had at least one child, right? So that's what this is on the x-axis, is the percentage of women who fall into this category. All right, so we can see that the chart doesn't start at 0; it starts at 50, and that's because we can basically save some space by chopping off 0 to 50. And then let's take a look at each one of these sections one at a time. Oh, the other thing to note here is that we've got 2 bars in each education category, and that the colors correspond with different years. Okay, so we've got the blue is 1997, and the orange or red bar is 2017. So looking here at the leftmost bin, as they are called, the MD or PhD bin of the histogram, we can see that, yes, indeed, over 20 years ago, far fewer of these women had children. In fact, only 65% of women aged 40 to 44 who had a doctoral degree of some kind, whether medical or otherwise, only 65% of them had children, at least one child, while today, or closer to today, back in 2017, nearly 80% of these types of women, this category of women, had at least one child. So that's a pretty dramatic increase there. And it's obvious because the visual nature of the chart too. So that's another reason we're as economists, we very frequently use charts, is because of their visual nature and how quickly they can convey information. Here in the next bin over under master's degree, the difference is not as significant, but still in the same direction, right? In 1997, roughly over 70% of these types of women with master's degrees, this age group of women with master's degrees, only just barely over 70% had at least one child, where in 2017, it was closer to, probably 77, 78% of these women. So an increase there. And we see that increase here in the middle bin as well for bachelor's degree. There's still that increase. So it seems that more women in the age group of 40 to 44 are having at least one child than 20 years ago. Now, for the last 2 bins, high school and less than high school, we actually see a slight decrease, which is interesting. But to be quite honest, this difference here is so small that it's probably not statistically significant, which means we can't say for sure that the number of women having children 20 years ago was less or more than today. That it's just too close to tell, right? So kind of like in elections when when you see on the news that the election is too close to call. It's because even though there is a margin, there is a gap. It's so small that statistically you can't differentiate it from being no gap, basically. But that's for a statistics class. So I'm trying to see if there's any other interesting things here. It seems to me that the blue bars go from smallest to largest in a very linear fashion, so that's interesting. So that's for 1997. So it looks like there's almost a linear relationship, perfect linear relationship between education and number of children. I'm sorry, the number of women having at least one child. Whereas for 2017, may not be linear. It looks like MD is actually higher than master's degree for 2017. So, although again, that may be a statistically insignificant difference there. But it does seem as though people who with lower educations do have more of them have children. So that's pretty interesting too. Now, just to give you a few reasons why we might be observing this. It could be, of course, that getting a higher education is very costly in terms of time and may be difficult to achieve if you have children. So that could be one reason we see this. People that have higher educations, fewer of them have children. There could also be something correlated with the level of education. Maybe people with higher educations are more knowledgeable and aware of contraceptives such as condoms and birth control and those sorts of things. I don't know. There's a number of things that could be going on, but I'll leave it up to you to think of some other reasons why we might see this pattern of data. All right, so that's chapter 1. We will look at Appendix A, which is at the end of chapter 1. But chapter 1 is complete, and at the end of every chapter, we go very quickly over just some of the summary of the discussion of learning objectives. So, of course, in section 1, we wanted to be able to define economics and talk about the difference between micro and macro. In section 2, we talked about these 3 basic economic questions: what to make and how much to make, and for whom. All right, and then the 2 opposing sets of answers, which basically, in most ways, equate to capitalism versus communism, but a command and control economy where the government is in control of all economic activity, aka communism, versus a market or price system, aka capitalism, where economic decisions are decentralized, made by independent agents within the economy, such as myself and yourself included. We are consumers, of course, and suppliers of labor. But in any case, in section 3, we talked about this rationality and self-interest assumption, and what role that plays in economic analysis. In section 4, we talked about why economics is a science. And then in section 5, we talked about the difference between normative and positive statements, or positive and normative economics. All right, that concludes section 5 and the end of chapter 1. I'll see you in the next video for Appendix A.